Welcome. This workshop, using engineering design to integrate civic engagement into K-12 learning, is designed to guide participants to either begin to build or evaluate a civic issue-focused lesson. This video includes a quick introduction to get you thinking about that work. We will use the NGSS, or Next Generation Science standards, as an example set of standards, but participants are certainly welcome to use whatever standards and guides they normally use to prepare to teach. Please be sure to have access to those materials during the program. I'm Kathy Browne, faculty member at Rider University in the Department of Geological, Environmental, and Marine Sciences. I'm a geologist by training. It turns out, if you compare the principles and ideals that have guided many Sensor members to create learning experiences, you will find that they're remarkably similar to the expectations for changes in science curriculum when one implements the Next Generation Science standards. Both emphasize the value in learning that focuses students on real-world matters of interest, learning and applying that learning to find solutions, integrating different disciplinary perspectives to do so, and guiding students to take responsibility for their learning and prepare them for productive citizenship. So, combining selected aspects of the NGSS with a civic issue can result in great learning, minimally because they can increase students' intrinsic motivation and can show students that they can contribute to solving pressing problems in the world. Most of today's science standards include the expectation of integration of several parts of the standards into individual lessons. In the NGSS and in the predecessor to the standards, the framework for K-12 Science Education, it is expected that student learning experiences include the intertwinement of three dimensions: the science and engineering practices, what scientists do to do science; disciplinary core ideas, the science ideas that have traditionally been included in standards; and the cross-cutting concepts, big ideas in science that transcend a single discipline and help students connect ideas across those disciplines. These three dimensions are summarized in these charts. Notice the color coding. These colors, blue for science and engineering practices, orange for the disciplinary core ideas, and green for the cross-cutting concepts, are used throughout the standards documents to help teachers identify the integration of the dimensions. We will use this color coding in our work. Notice that the engineering design occurs in two places, within the science and engineering practices and as its own section in the disciplinary core ideas. So not only should students learn the engineering design process, they should learn it by engaging in it to also learn science. The NGSS also expects that students learn science by investigating natural phenomena, rather than just learning a bunch of facts. So if we guide students to learn and apply science to address pressing issues, you can move them into engineering design as well as investigate natural phenomena. For example, a science idea that students typically learn is density. It's very difficult to observe directly. But if we engage students in investigating how different wood types behave in water, a phenomenon that they can observe, they must make sense of density and density differences. If they instead are asked to figure out best materials for a boat intended for a specific purpose, they can learn many things, including density and density differences, while addressing this design need. In fact, to solve any natural phenomenon-related problem, engineers move in and out of the science inquiry and engineering design process. The NGSS addresses this iterative approach through the three component ideas in the center here, and here explained in more detail. To define and delimit a problem, one needs to know relevant science or learn it in order to do this step. To create and test possible solutions, one needs to apply that science and likely learn some new science given results from the testing. And to optimize solutions, one needs to be sure the relevant science is considered. And remember, the NGSS, and likely most other standards, expect that engineering design is not only learned but also practiced. And the use of one or more cross-cutting concepts like systems or energy would likely be useful big idea lenses to guide the intended learning. So those expectations and content standards, in fact, encourage an iterative process in the student learning experiences of both science inquiry and engineering design. Join us for this workshop, and we'll guide you to either begin to design a civic issue-focused lesson or evaluate some available online that we've just discovered, or even your own. The facilitators for this program will bring expertise in curriculum design, science education, various sciences, and the NGSS. And we expect that participants will also possess expertise that we can leverage. Be sure to bring access to your own materials so you can reference them in the work that you do. In case you're interested, here are a few resources you can check out. First, provide some additional information about the engineering design process in the NGSS. The second, some of those example lessons we've just discovered. And the third is a set of comprehensive lesson design materials for middle and high school students vetted by Sensor colleagues and created by some of the facilitators with us at this program. We hope to see you at the workshop.